Hi, Algebra 1. We are going to look at the homework, which was page 37 in the yellow book. So we want to identify the rate of change. So problem number 1, they have n, g at n, and then they have 1, 2, 3, 4, and then 12, 9, 6, 3. Okay, it looks like I'm subtracting 3 each time, right? And this way, I'm adding 1. So we're going to take this and make it a fraction over this. So the rate of change is -3 over +1. You might have heard the term slope before. That's the same idea. If you look at the other problem, we have a graph. I have some dots as they're coming down. And you'll have to count on your worksheet. It looks like they're counting by 5, so each little line here is 1. Okay, so if I go from this top point to this point, I'm going to go down a certain amount and over. So if you count on your worksheet, from the very top point, you're going to go down 1, 2, 3, and then you're going to go right 1. So you go down 3 and right 1. Okay, so notice that's the same as that. So -3 over 1. That's the rate of change. So the rate of change, it says what is the rate of change in the middle, right after those? And it's basically the slope. It's the change that's taken place in the y direction over the change of what it's doing in the x direction. So the change in the vertical direction over the change in the horizontal direction. Problem number 2. Yeah, h of t. Five. Oops. That was equal 5. 3 raised to the t. And then they say d at t is equal to 7 minus 9 t minus 1. Okay, so for letter A, they said they want h at 4. Well, that's going to be the green one, so that'll be 5 times 3 raised to the 4th, which 3 to the 4th is 3 times 3 times 3 times 3, which is 81, so this is 5 times 81. So that's going to give me 405. For B, we'll do it in purple. They want D at 2. And the reason I'm using this bottom equation is look at the letter, which is going to give me this. So do the math. That's going to be 2 minus 1, which is going to give me 1. 9 times 1, which is going to give me 9. So 7 minus 9 is -2. Letter C, they want us to go back and use the H equation, so the green one. So 5, 3 raised to the 0. 3 to the 0 is 1, so I get 5. And then the last one, D at -3, we're going to use the other equation up above. So I'm going to go 7 minus 9, -3 minus 1, which is 7 minus 9. That's going to be -4. If you multiply those together, you're going to get +36. And that's going to give me an answer of 43. And that's basically the homework. There's a worksheet I will be giving you. And what we're going to do on this worksheet today is we're using it as a review. So what I'll do is I'll ask you to pause the video and try it and then see if you can figure out what the answer is saying or if you get the correct answer. So once you have the creek, it says at the very top, practice B, arithmetic versus geometric. Practice B, it's a worksheet I'm giving you. So let's take a look at that. All right, so this is the equation. Let's make sure I'm ready to write on this. Okay, highlight, no, I want to write on it. Let's see if I. Okay, I've loaded this. This looks a little bit different than your sheet, but the same problems. So let's take a look at what we have. I have to modify this down here a little bit. So we have 0, we have a blank, 1, -7, 2, 3, 3, 13, 4, 23, 5, blank. Okay, so let's take a look. What am I doing from each of these terms? What does it appear that's taking place? We're adding 10. So we know right away it's got to be arithmetic. Okay? It's arithmetic because we're adding. Okay? We don't know what my first term is, so what would I have to do if I went backwards this way? I added if I went to the right, so I'm going to subtract. So that'll be a -17. Okay? Now remember, I want this term here. This is our first term. Okay, so our explicit is going to be next plus 10, something like that. Our recursive, we're going to use f at n. The reason I'm using f at n is because of this. Okay, so remember, as long as this is a 1, this is going to be my first term, and then I'm also going to use that I'm adding 10. So it's going to be 10n. The reason it's n is because that's my letter I'm using. And then -7. That's our recursive function. Go ahead and take a look at number 2 while I am changing it a little bit. Looks like I have to modify. So we have n. See if you can be figuring out some of these problems. Okay, did you figure out what we're doing to get to the next term? Are we adding? Are we subtracting? Are we multiplying? Are we dividing? Well, it looks like I am subtracting 0.6 each time. Okay, so if I subtract 0.6 from here, that's going to take me to 9.8. If I subtract 6 from that, that takes me to 9.2, so we figured that out. We're adding and subtracting, so this is going to be arithmetic. So a few things I want to look at. This is my first term and my difference. So my recursive function is going to be next minus 0.6. My explicit, we're going to use f at n because I have that, is equal to negative 0.6n. The reason I'm using the n is that I have that. And then plus 11.6 because of that first term there. Doing okay? If you have any questions, make sure you ask me. All right. Why don't you try number 3 while I write it down so I can take a look at it. Okay, so what looks like it's taking place? Looks like I add 14 here, but I don't add 14 there, so that might not work. How did I get from here to here and then here to here being the same math operation? It's not adding, it's not subtracting. If you said multiply by 2, you got it. So because I'm multiplying by 2, this has to be a geometric sequence. Okay? And how do you know that it is? Because I had to multiply to get the next. So my recursive function is going to be next times 2. My explicit, let's figure out the rest of this. So I had to multiply 2 going this way. What do I have to do to get this way? What undoes multiplication? Right, division. So 14 divided by 2 is 7. And then 56 times 2 is going to give me 112. Okay, so I want to use this. That 14 means something, and the times 2. So remember, when I do my explicit function, it's going to be, I'm going to use f at n because I have this equals, my first term is 14. And then my multiplier is times 2. I'm going to raise 2 to the n power. Now, if that was 0, if we were using this term, we'd have to have this be a -1, but we're not using that. We have the first term, which is fine. Go ahead and try number 4. And I have to rewrite it. Give it a try while I'm rewriting it. Okay, what does it look like I'm doing going from this term to this term? Am I adding? Well, I'd add 6. If I add 6 to that, I don't get to 32. So that doesn't work. Subtraction doesn't work. What do I do to 2 to get to 8? What do I do to 8 to get to 32? Right, I multiply. If I multiply by 4, and this is going to get kind of big, so times 4, that's 828 times 4. That's just too big. I'm not going to worry about those. I mean, if we had a calculator out, I would do it, but I don't have a calculator with me. So our recursive is going to be next times 4. Okay. I'm going to start, when I have the 1 right here, I can start with that very nicely. If I start with the 0, my exponent is going to have to be n minus 1. We're not going to do it. So our first term is 8. So I'm going to go f at n, because I have this, equals 8 times, what am I multiplying by for? I'm doing 4, and then I'm going to raise that to the n. Okay, now let's take a look. Is this going to work? Is this going to work with what we have? If I raised 4 to the first power, I get 4. 4 times 8 is 32. So we might want to go n minus 1 here. And the reason I'm going to do that, if I plug 1 in, 1 minus 1 is 0. 4 raised to the 0 is 1. 8 times 1 gives me 8. So that's important. Make sure you double check. In fact, let's go back to this top one and make sure we did it right. So I wanted to make sure I got to 14. So if I got to 14, oh, you know what I have to do? I need this n to become a 0 because my first term. So if I make that -1, if I plug this 1 in, 1 minus 1 is 0, 2 to the 0 is 1, 1 times 14 is 14. So you got to double check on both of those. I made a mistake. Sorry about that. But it's always good to double check your work. Now let's go to the back side. Take a look at number 5. Okay, and looks like I'm going to have to redraw this one. I'm going to read what it says at the top on that worksheet. It says a class has 20 students. A class of 20 students learns a rumor. 1 hour later, each of those students tells the rumor to 2 friends, who then tell 2 more students in the next hour, and so on. How many students learn the rumor each hour? So I have n. We have f at n. There was 20 students that heard right away, and then we said each of these students here told 2 friends. So this is going to be times 2. So that would get to 40. And then after 2 hours, multiply by 2. It gets me to 80. After 3 hours, that gets to 160 because I'm multiplying by 2. After 4 hours, that gets to 320. Times that by 2, that takes me to 640. Okay? Because we're multiplying, that means this has to be geometric. Okay? So let's try and figure out our equation. So let's look here first, and let's look here. So I'm going to say f at n equals, well, let's do the recursive first. It's going to be last times 2, and then I'm going to say my first term is 40, and then I have times 2. I'm going to raise 2 to the n power. Now let's see if we can get this 40 by plugging in this 1. 2 to the first power, if I plug 1 in there, is 1. 2 times 40 is 80, so I get that. So this is one of those I want to make sure I subtract 1 on. And that's my function. Okay. If you double check this, you can take a look and say, wait a minute, if I plug 1 in, I get 40. If I plug 2 in, even if I plug 0 in, which gives you one of those negative exponents, which we talked about the other day. Okay, but that's your answer. Number 6, we're starting this with dots. We're just trying to draw their picture. 1, 2, 3, 4. 1, 2, 3. 1, 2, 3, 4. Okay. So they want us to fill in the graph. So we have n and we have f at n. So this is at 0, n equals 0 as they have listed. There's 5, n equals 1, n equals 2. So at 1, if you count the dots, I have 5, 6, 7. It looks like there's 8. At 2 hours, I have the same thing. It looks like I'm adding 3 more. So that's 11. At 3 hours, add 3 more to that. At 4 hours, add 3 more to that. At 5 hours, add 3 more to that. So we filled out our whole grid below. Our recursive is going to be next plus 3, it looks like. So if I'm adding 3 each time, which is this going to be? It's going to be arithmetic. So if it's arithmetic, we need to figure out a few things. All right, so let's take this, looks important, and this plus 3 is important. So I'm going to use f at n for our equation, because that's what I have, equals 3 times n plus 8. So let's take a look. Did we do this one right? So let's take 1 and plug it in. 3 times 1 is 3, plus 8 is 11. Ooh, so what do we have to do to this? Yeah, we might want to go n minus 1 plus 8. Okay, and the reason why this works this way, take a look. If I use my day 0 and put the 5, I'm going to get the answer right. Okay, but I'd use day 1. So if we use day 0, if we knew day 0, watch what our equation is going to be. We still know we have the 3n plus 5. Well, I said it was this, okay, because I tried to use this first term. Well, take a look. Can I distribute this over? And if so, if I take care of that, negative 3 plus 8, I get positive 5. So these are basically the exact same function. So maybe if you start looking at 0, but sometimes look at the first term, sometimes look at the 0 term. It's just playing around with it. Take a look at number 7. Number 7, we have n, f at n. And number 7 says, Danny has saved $150 in his bank account. Each month he deposits $40 in his account. So I get 0, 1, 2, 3, 4, 5. So he started with $150. And then each month he added 10. So 160, 170, 180, 190, 200. Okay, so he's adding 10 each time. So if he's adding 10, this has to be arithmetic. Okay, so let's figure our equation. Heck, let's use this right here to see if we can make it work. Okay, so I have, and I'm going to use that. So f at n equals 10n plus 150. Okay, if I plug the 0 in, 10 times 0 is 0. 0 plus 150 is 150. That worked. Let's see if I plug this 1 in, if it works. 10 times 1 is 10. 10 plus 150 is 160, so on and so forth. So that works. So this is our explicit function, and our recursive function would be last plus 10. All right, last problem on this page, number 8. They want to know if it's arithmetic or geometric. So it looks like it says, the word problem says, a man is sick without knowing he accidentally gets 3 friends sick day 1. sick 1 day later. On day 2, those friends spread the virus to 3 more friends, and so on and so forth. Okay, so let's figure out our pattern here, our table. We're just going to look. So day 0, the first person is sick. At day 1, 3 people are sick. And those 3 people get 3 more people sick. So that's going to, oops, on day 2, that means, looks like he's multiplying by 3. So that's going to give me 9. At day 3, there's 27. At day 4, you have, was that 81? And at day 5, we have 243. Ooh, lots of people getting sick. So we're multiplying each time by 3. Because I'm multiplying by 3, this means it has to be geometric. And because we are starting with day 0, let's start with that. So I'm going to use f at n, because I have here, is equal to our first term, which is 1, times 3, and I'm going to raise 3 to the n. All right, so let's see if this math is going to work. If I take the 0 and plug it in here, 3 to the 0 is 1. 1 times 1 is 1. Okay, that worked. Let's plug 1 in. 3 to the first is 3. 3 times 1 is 3. That worked. Let's plug 2 and see if it works. 3 to the second is 9. 9 times 1 is 9. Oh, cool. So this is our explicit function, and this is our recursive function. So it's going to be, our recursive will be next times 3. Okay? I'm now going to have us take a look at this worksheet. I'm going to hand you out another worksheet. It looks like this, and what I would like you to do is work on it together, see if you can figure it out. And I will put up on the wall in a couple locations around the room. You can walk up and double check if your work is correct. Okay, we will have a quiz tomorrow. It's based on all of this. Okay, so make sure you're here. Have a nice day, my friends. Bye-bye.